All right, today is 5.5. We're talking about solving systems of conic sections. So when two graphs intersect, both the x coordinate and the y coordinate of the graphs are equal at the point of intersection. So the x on one graph will equal the same as the x in another graph, and the y in one graph will equal the same as the y in another graph. So let's go ahead and solve this first system of equations. So in this one, we have x squared plus y squared equals 25, and we have x minus y equals -1. So since I have an x squared and a y squared here, I know that I need to get one of these equal to x or y and then square it. So I'm going to go ahead and add y to both sides, and I get x equals y minus 1. Okay, so now I need to square that. Okay, so I'm going to do y minus 1 times y minus 1. Remember that it's not just y squared and -1 squared. You have to FOIL this. Okay, so I'm going to get y squared minus 2y plus 1. All right, and now I can go on ahead and plug this x squared back in. So I have y squared minus 2y plus 1 plus y squared equals 25. Combine my like terms and I get 2y squared minus 2y plus 1 equals 25. Okay, this is a quadratic, so I'm going to have to set it equal to 0 and factor it to solve. So 2y squared minus 2y minus 24 equals 0. I can take a 2 out. I'm left with y squared minus y minus 12. Okay, so if I factor this, so when I set 2 equal to 0, 2 is never going to equal 0, so that won't work. So I'm going to go on ahead so I can cross that one out. So I'm going to factor this and I get y minus 4 and y plus 3. So y is going to equal either positive 4 or -3. All right, so now I'm going to take both of these values and plug them back into my original equation. One of them, it doesn't matter. I'm going to actually plug it into this x equals y minus 1 because it's going to be the easiest one to plug it into. So I get x equals 3. So I'm going to get 3, 4 for one of my answers, and x equals -3 minus 1. So x equals -4. So then I'm going to get -4 and -3. And those are my two answers. So that's where these two graphs will cross at these 2 points. Let's go ahead and do the next one here. So I see that I have a y equals, and then I have an x plus 1 squared here. I see that I have an x and a y in this equation. Well, if I have a y equals, I can get this equation set equal to y, and then I can just set both of those equal. So I'm going to add 2x to both sides, and I get y equals 2x plus 3. So now I'm going to set this y here, substitute it in, and I can set both of these equal to each other. So x plus 1 squared minus 2. Okay, I need to do x plus 1 squared. So I get x squared plus 2x plus 1 minus 2. Okay, now I'm just going to combine like terms. X squared plus 2x minus 1. Now I'm going to move everything to the same side. And I get 0 equals x squared minus 4. Well, this is a difference of squares. So that's going to be x plus 2 times x minus 2, which means x is either going to equal -2 or +2. So I'm going to take both of those and plug them back in. I'm going to plug them back into this one right here because it looks like the easiest one. So 2 times -2 plus 3, and y equals 2 times +2 plus 3. So that's -4 plus 3 equals -1. And this is 4 plus 3 equals 7. All right, so my answers are going to be -2, -1, and 2, 7. All right, 2 more here. So let's take a look at the next one. So here I can see that both of these are equal to 1. So I'm going to set both of these equal. I don't even have to move anything. So I have y squared over 16 plus x squared over 4 equals, and now I'm going to set it equal to this other one, y squared over 16 minus x squared over 4. I need to get everything to one side, so I'm going to subtract y squared over 16 from both sides. That's going to make those go to 0. And now I'm going to add x squared over 4 to both sides. So this one right here, make sure you're looking at your signs because that's a common error. So x squared over 4 plus x squared over 4 is 2x squared over 4. Okay, equals 0. I can simplify that. So the 2 and the 4 cancel, and I get x squared over 2 equals 0. Now I need to solve. So now I'm going to get x squared equals 0. Okay, so now I'm going to go on ahead and I'm going to plug this back in because when I take the square root, I get x equals 0. So now I'm going to get y squared over 16, doesn't matter which one you plug it into, equals 0 over 4 equals 1. So that's y squared over 16 equals 1. Multiply both sides by 16. And I get y squared equals 16. Take the square root of both sides and I get y equals plus or minus 4. So my answers are going to be 0, 4, and 0, negative 4. All right, let's take a look at this last one here. So this last one, I have a 1 here and I have a 1 here. So I'm just going to change this to y minus x plus 1 squared equals 1, because then I'll be able to set them equal. But I'm going to go ahead and square this x plus 1. Actually, I don't have to. So we're going to go ahead now and set these equal. So x plus 1 squared over 25 plus y plus 2 squared over 4 equals y minus x plus 1 squared. I'm going to add x plus 1 squared to both sides. Okay, so that, and in this case, it's going to have to add 25x plus 1 squared over 25. Okay, so that's going to be 26x plus 1 squared over 25 plus y plus 2 squared over 4 equals y. Well, my question now is, will that ever equal that? Will I be able to combine those? No, I can't. So in this case, it's looking like there's going to be no solution. Okay, and if we go on ahead and we graph this, just sketch it on a graph, we're going to wind up with -1 and -2 for this ellipse here. And we're going to have 5 out and 4 up. Okay, so we're going to have an ellipse here somewhere. And then this one is a parabola starting at +1 and -1. So it's starting here and it's going up. So you can see that these are actually never going to intersect. Okay, so that is no solution. All right, so that was all of chapter 5. Have a great day.